Okay, place value in the decimal system and changing regular fractions, standard fractions, to decimal fractions is what we'll be talking about on this video. When we talk about the decimal place values, it's really the same as the whole number. They're decimals too, because decimal just means something based on 10. But normally in mathematics, when we refer to decimals, we're talking about these fractions that are down here to the right of the decimal point. And they are interesting fractions in that they only have certain denominators, and the denominators fit right into the base 10 system. The first denominator that we have in the decimal fraction side is the tenths. And a tenth is one whole broken up into 10 pieces. And here's where we can see the consistency in the system. So 10 of these tenths make one whole. And so we haven't lost anything in regard to the way the system works. This is the hundredths place. Notice that I'm trying to say the THS ending on it because that distinguishes it from a whole number. If you had 10 hundredths, you would make 1/10. And if we go down to the third place, it would be the thousandths, and 10 thousandths would make 100th, 10 100ths would make 1/10, and 10 tenths would make one whole. Here are 4 different decimal fractions. They each have 4 digits, and they have one that is highlighted in a blue font. So if we take a look at each of these individual digits and the place that it's in, we can take a look at its value also. This 3, just to the right of the decimal place, or decimal point, is the first decimal fraction. It's 3/10. It's a 3 in the tenths place. If we were writing it as a standard fraction, this is what it would look like. This blue digit in the second value is in the hundredths place. So it's 1 is the numerator, and hundredths is the denominator. That's what it sounds like when we say it. And that's what it looks like when we make it into decimal fraction form. Notice you don't see the denominator. It's all according to the place that it's in. Next we have this 9. It's in the third place out from the decimal point. That would be 9 thousandths. If we wrote it like a regular standard fraction, we'd see the 9 and we'd see the denominator here. But in the case of decimal fractions, we just need to plug that 9 into the right place, and then we know what it is. Going one place further, the 3 is in the 10 thousandths place. That's how we would write it as a regular standard fraction. And here we just put the 3 into the place. You can probably see how these places are being named. They're really going without a ones place because you wouldn't have ones in fractions, starting with tenths, hundreds, thousands, 10 thousands, and on and on and on, the opposite direction as the whole number values. Now, why does that make sense? Well, first of all, these are decimal pieces that we're breaking the whole into. So as the number gets larger, the pieces get smaller, so it stays with that consistency. As you move to the right, the values get smaller. Well, which one of these blue digits is the largest value? Well, hopefully it makes sense that it has to be the one in the largest place. 3/10, just by being tenths, is larger than any of these other smaller pieces. Well, let's take a look at these 4. Okay, we have 6/10. This is called 16, and the last digit in the numerator comes out to the thousandths place. That's how we can identify the denominator. 43, and the last digit is in the hundredths place, and back to the tenths place again, 9/10. Well, if we were placing them in order, let's go from largest to smallest. The largest one would be 0.9, or 9/10. Now, I wonder if you understand why. Well, one thing that you can look at, if this is the largest place that has the biggest places, we could just look here to see which number has the largest digit in this place. And the 9 far outdistances the other numbers. It's bigger than 6, bigger than 4. Well, certainly bigger than 0. Okay, so that makes 9/10 larger than whatever the others may be. This may have more digits, but surprisingly isn't the largest number. Hopefully not too surprisingly. Okay, how about the second value? Well, the second value would be, after 9, would be 6. So we have 9/10, 6/10, and here we have a 4. It's between these two now. We have a 4 in the tens place and nothing in the tens place. Well, 4 in the tens place is going to trump 0, and so the 0.016 goes all the way down as the smallest of the values. Here's another way of looking at it. By making them all the same size. If we make them all the same size, well, how would we do that? Well, this is 16,000, so that means the denominator size is thousands. And almost the same as making common denominators, let's bring all of these out to the thousands place. Well, how would we do it? Well, just by adding some zeros. If I add 2 zeros, I add a 0 to include the hundreds place, and now I'm out to the thousands place. I do the same thing here, and on this one we'll only need 1 0. Okay, now we have them all as thousands. This is 900,000, 600, 430, and seeing where they're all the same size pieces, the one with the most of those pieces is the largest, on down to the smallest, little 16 thousandths. Now, some standard fractions, such as these, are very easy to change into decimals because they have a denominator that's the same as one of the decimal denominator places. For instance, this first one, 3/10, all you really need to do is recognize that that's the tenths place. Okay, all we need to do is put a 3 in the tenths place. This is the thousandths place. We're going to have 13 down to the thousandths place. We'll have to write it like this. See, we get the last digit in the thousands place. We get the 10 in the hundreds place. And let's think about this. This makes sense. 10 of this place value makes 1 of the next place value, just like with whole numbers. And of course that important 0 holding the tenths place, telling us there's nothing there, but there still is a place. And that forces these to go back where they belong. And this last one, the same thing. The 6 needs to be in the hundreds place. When we plunk it in there, we have to hold the tenths place with a 0 because there aren't any tenths. Okay, those are pretty easy to see. Well, let's go back and see if we understand for sure how to put things in order of value with decimal fractions. Okay, here again is 4 different fractions. Which one is the smallest? Now remember, it helps to look at just that largest place. And if you're thinking along with what we just talked about, you probably pick this one. This one doesn't have any tenths at all. So how can it compete with fractions that have tenths in their value? In fact, this doesn't even have any hundreds. It goes all the way down. All it is 7 thousandths. Okay, once that is chosen as the smallest, what would be the next one in the list? Well, it should be the 5. 5 is certainly smaller than 6 and smaller than 7. That's going to be the next one. Now it's between these two. They're fairly close in value, but the 7 here makes it more valuable than the 6 being here. No matter what goes beyond it, remember these are all smaller, so they can never overcome the fact that this is shy in the tenths place. So that's the third one in order. And finally the 7/10. Once again, if we were to add the zeros in, bring them all out to the thousands place, well, now we can just call them thousands. And 7 is smaller than 500, which is smaller than 630, which is smaller than 700. So looking at them as the same size denominator, they also keep that same order. Remember, the first thing you want to do is look at the highest place. Now sometimes, just like in alphabetizing, we can have them tie with a letter, and they could tie with a place, and you'd have to go on to the next place. That didn't happen here, though. Okay, this is a metric stick. It isn't the way I would like you to see it, but hopefully you can understand that the stick is so large that it's broken up into 4 different parts. 1/4, 2/4, 3/4, and the last fourth. So a metric stick is a great way to show. Actually, we can compare the values that we just looked at in the previous slide. But let's try to understand the stick first if you're not familiar with it. It has a lot of little hash marks on it, little units, larger units, and they make up the entire whole meter stick. A meter is just a little bit larger than a yard. You can see if it was equivalent to what we normally use in inches and feet, it would be equal to a little bit over 39 inches. Okay, but we're just talking about the metric side of it now, which deals all the time with decimals. Okay, we have these very, very small little units here. They're almost so small we can't even see them. Okay, those are called millimeters. And each millimeter is 1/1000th of the whole meter. If you took one little millimeter here, it's 1 out of 1,000 that you would need, because you'd have to have 1,000 of them put side by side to make the entire meter. Now, if you counted them up, you'd get to this number, which is the next unit that's important. This is a centimeter. You have 10 millimeters, and you make 1 centimeter. A centimeter by itself is 1/100th of the whole meter stick, because they're numbered here. And you see the numbers keep on going up until you get all the way up to 99, and one more makes 100. So 100 centimeters makes an entire stick. 1 would be 1 out of 100, or the decimal fraction 1/100th. Well, we had, if you remember correctly, the smallest value in the previous slide was 0.007, 7/1000ths. Well, that would be the same thing as 7 millimeters. And so 7/1000ths of this entire meter stick would be way down here. It's just a very small amount, because it doesn't have any tenths. These would be the tenths right here. And it doesn't have any hundredths. Now the next one was 0.5. Now 0.5 is the same thing as 1/2. So 0.5 brings us up here halfway along the whole distance of the meter stick. If we were talking about it as just millimeters like this is, half the stick would be 500 millimeters. Well, the whole stick is 1,000. Kind of makes sense that a half would be 500. The next number was 0.63. Okay, that's 63/100ths. Another way of saying it is it's 63 centimeters. So it's right on the 63 centimeter mark. If we're talking about millimeters, remember there's 10 millimeters for every centimeter, so 10 times 63 would be 630 millimeters. And the last value that we were comparing, which ended up being the largest one, was 0.7. And 0.7 would bring us right up here to 7/10ths of the entire meter stick. That would be 70 centimeters. That would be 700 millimeters. So we can see visually how those fractions definitely did have a difference and where they fall in regard to the whole.